Hi everyone, I'm Adam. In this problem, for a given polar equation, which you have as r squared equal to cosine theta, we're going to convert that to rectangular form. Now, to start with, we have these conversion equations when we would deal with coordinates. And if we wanted to convert, say, polar coordinates to rectangular coordinates, we could use the equations x equal to r cosine theta or y equal to r sine theta. And from rectangular coordinates to polar, we had tangent theta equal to y over x, or r squared equals x squared plus y squared. Now we're trying to convert equations from one form to the other. You don't have to stick with one bunch or the other. You can kind of mix and match to see whatever you need. So as we're going to see, we're going to pull from both sides. Okay, so let's get started. So let's take our polar equation, our r squared equal to cosine theta. All right, and what we're trying to do, converting from polar to rectangular, is we're going to take basically our equation in terms of r's and thetas, and we want to convert that in terms of x's and y's. So let's see what we can do. Well, we have an r squared, which we see r squared is x squared plus y squared over here, and we have a cosine theta. And what can we do with cosine theta? We know if we have r times cosine theta, that would be equal to x. So actually we're going to start there. We'll get to this x squared, y squared in just a moment. So if I multiply through both sides by r, because I want to get r cosine theta here, that's what we'll do. So we'll multiply both sides by r, and so at least over here, right, that's going to give us r cosine theta is x. And as we said, r squared is x squared plus y squared. So we have that taken care of, and what about r? Well, if we come back to this equation, want to solve for r, just take the square root of both sides. So that means that r would be positive or negative, say square root of x squared plus y squared. So we can substitute that for r. So let's go ahead and rewrite it, clean it up a bit. So r, right, is positive or negative. We'll write it as x squared plus y squared to the 1/2 power times r squared, which was x squared plus y squared, and that is all equal to, say, x. Okay, now technically we're done. We've turned everything from r's and thetas into terms of x's and y's, but we'll go ahead and try and clean it up just a little bit. So we see that we have x squared plus y squared to the 1/2 and x squared plus y squared to the 1st power. So we can actually combine these. So the left-hand side, the plus minus will stay, but it'll be plus minus x squared plus y squared to the 3/2, and that's equal to x. And we can take this a little bit further. So if we want to get rid of this 3/2 power, and especially maybe this plus minus, if we notice, if we want to get rid of the 3/2 power, if we raise both sides to the 2/3, go ahead and do that on this side, well, our 2/3 cancels with our 3/2, but notice the 2 in the 2/3 is actually a squaring. So whenever we square something, it changes it from negative to positive. So this plus minus is just going to go away essentially. So we're going to be left with x squared plus y squared, and that's going to be equal to x to the 2/3. And we can actually take this just one step further. We'll bring over our 2/3 to the left-hand side by subtracting it. So our equation in the end can be written as, say, x squared plus y squared minus x to the 2/3 equals 0. So there's our equation in rectangular form and simplified. So there we are. Thank you very much.